open.
Good morning, afternoon, or evening. Calculus people, I'm just going to do a very, very quick extra critical number question here. In my last examples there on the last day, I didn't really talk about intervals of increase, decrease as much as maybe I should have. So I'm going to throw in one there, extra example for you guys here. So we're just going to look at finding critical numbers, finding the areas of increase and decrease, and we're going to look at a simple example for that. Okay, so we'll pop open our Blackboard. It shouldn't be too long of a video, I hope. And then you'll just have something else you can take a look at when you're looking at critical numbers. Okay, and then next day we'll be looking at the second derivative test, which talks about concavity. Okay, so we're just waiting for the Blackboard. There we are, popping open. Okay, so let's set ourselves up here. Okay, this is an extra critical number interval question. Okay, just an extra one. Okay, so for the following curve, find the critical points the intervals of increase and decrease, and the max and min value. Okay, I didn't do specifically intervals of increase, decrease, so I'm going to throw one in here. Let's do a simple curve. Let's do f of x equals x cubed plus or minus 3x squared. Okay, we'll throw it in here. F of x, or y if you like, equals x cubed minus 3x squared. That should be a nice, easy one. Okay, hopefully I didn't do that one already. Let me just double check to make sure I didn't. Okay, it did not. You have to quickly check there. Okay, critical numbers. So we go f prime. X is what we want to find, or y prime x, depending on how you're writing it. So 3x squared minus 6x. Okay, that's our derivative. Okay, we set our derivative to 0. That's a flat spot or a critical point. And we solve for x. Now, how do we solve for x? We can factor out a common factor of 3x. Okay, so we have now two possible critical points here. Okay, 3x can equal 0, or x minus 2 can equal 0. So x equals 0 or x equal 2 are our two critical points for our x. Okay, so let's plug in our numbers to get the y point. F of 0 equals 0 cubed minus 3 times 0 squared is still 0. So one critical point is at 0, 0. Our other critical point is at f equals 2. So 2 cubed minus 3 times 2 squared. So this would be 8 minus 3 times 4. So that's going to give us 8 minus 12, which will equal a negative 4. So our other critical point is at 2, negative 4. So there's our critical points on our for our graph, right? Okay, that's our first step. Our second step is to do a sign analysis of the factors of the derivative for finding the slope changes. Remember, the derivative represents slope, so if we do that, we'll slide this down a little bit. We draw a little number line here, and we've got our 0 point and our 2 point. Okay, we got our two factors, 3x and x minus 2. Okay, 3x is 0 right there. I guess we just put a 0 there. That looks stupid. Okay, at that point, it's 0. Below that point, it's a negative number. Above that point, it's a positive number. Okay, I guess I should draw this a little bit better because I got it running into my other question here. Next, so let's do that sign analysis with a little more space. 0, 2, okay, we have 3x and x minus 2. Okay, it's 0 there. It's below that, negative. Above that, it's positive. Okay, and then over here, x minus 2 is 0 at 2. Below that, it's 0. If we put a negative number in there, put in 0, you get a negative number. Put in 1, you get a negative number. Put in a negative 1, you get a negative number. Above it, you get a positive number. So here we have, for the whole thing, from here to here, we have negative times a negative. That's a positive. We have a positive times a negative. That is a negative. And then here we have another positive times positive. And this is basically for 3x times x minus 2. That's our intervals right there. So then we could say, okay, therefore, it's increasing where it's positive. So it's positive from negative infinity to 0 and from 2 to positive infinity. Right? And then it's decreasing in the middle here. Okay, and that's decreasing from 0 to 2. Okay, from 0 to 2, not square bracketed because it doesn't include those because that's a flat spot. Okay, and then where is there a minimum and where there's a maximum? Okay, this one's going positive, flat, negative. So this here point would have that. This point would have negative, flat, positive, negative, flat, positive. So this is a min, and this is a max. So here we can say that there is at 0, 0, we have a max point. And here at 2, negative 4, we have a min point. Makes sense because it's negative 4 is lower than 0. And that's how you would do those types of questions. Okay, so I'm going to throw that extra video in there. If you're working on the problems or if you had it worked out already, that's fine. Just to help us out. A little bit extra. Short little 9-minute video.